talk about ground fault detection on a delta system. And we know this is a delta system by the way it's drawn there, like the triangles. Again, if you need to know more about how the delta system works, you could go to other videos. But we're going to talk about what happens in a ground fault situation with ground fault detection on it. We're not going to go too much into the theory of what exactly happens at the ground fault if any of these lines get grounded, aside from the fact that it's unlike a neutral system where a fuse would blow or a breaker would trip. That doesn't happen with a delta system because there is no ground reference point for it to associate with. Now here I've got a Y ground fault detection system set up against a delta system up on top here. Let me just get my little pointer working. Now, you notice I've got this Y system set up. Again, it looks like a Y, and I've got it grounded here. That's going to be very important when it comes to our ground fault detection. Now, with that grounded point there, we're going to be able to see, and I've got these drawn as resistors, but typically what these resistors are, not typically, almost every time I've ever seen them, are their light bulbs. So these light bulbs would be rated for a certain voltage. Let's say that this, we'll assign voltages to these in a second, but in a good system, if this is running, you're going to get a phase voltage across this light bulb, a phase voltage across this light bulb, and a phase voltage across this light bulb. So when the system is running well, all three light bulbs will be lit up. When we actually have a ground fault, something else happens. So I'm going to go through what happens and why. Let's start out by assigning to this transformer a voltage. Let's say it's 208 volts on the delta. So using delta, we know that our line voltage and our phase voltage are the same. So we're going to end up with 208 on the phase. We'll end up with 208 volts line to line. Now with this ground point and having this ground fault detection set up in a Y configuration, we end up with 120 volts coming on line to line, but then with that neutral there, that allows us to see a phase voltage of 120 volts. So I will have 120 volts across that light bulb, 120 volts across that light bulb, and 120 volts across that light bulb. So if you show up to work in the morning, and this has happened to me at many plants where you go and you take a look and you see that all three light bulbs are going, you know everything's good on that delta system. Now let's throw a little wrench into the plan here. Let's throw a ground fault. So this ground here, there's a ground fault on line A. I've labeled the lines here, A, B, and C. So this would be line A, which also goes down to this light bulb. Line B goes over to this light bulb. Line C goes over to this light bulb. Now that we have a ground fault occurring, something strange is going to happen to these three lights. With A line being grounded, this is ground, which is the same potential as ground here. So we have a ground fault up top, we have a ground at our point here, which means that this point and this point are the same potential, which means that this point over here and this point over here are at the same potential. If that is true, then I have no potential difference across my light bulb. If I have no potential difference across my light bulb, then the light is not on. So this light bulb in a ground fault situation will go out on, if the ground fault is on A, this one would go out. If it's on B, it would be the same thing. I'd see B go out. And if it's on C, I'd see C go out. There you go. I've got 0 volts across that resistor. But there's another issue that's at hand here, is that I now have this resistor still gets voltage, but we'll talk about what that voltage is in a second, as well as this one. Now, they aren't going to stay the same brightness, because what's going to happen here is this ground point here is the same potential as up here, which means that this ground point here is the same potential as line A. If I go on my delta system C to A, I'm going to get 208 volts. Down here, C to A, I'm going to get 208 volts. Same thing over here, B to A. If I did it line here to line here, typically I would get 208 volts. Well, it's the same thing here because this is become A as well, so I'm going to get 208 volts on that one. So there you go. In a ground fault situation, 0 volts on this light bulb. This light bulb has now gotten brighter because it's 208 volts because it's getting line voltage, not phase voltage anymore. And this one gets 208 volts, so it gets line voltage, not phase voltage anymore. And then you get the joy of trying to find out where this ground fault is on line A, and that can be very tricky. And you industrial electricians or commercial electricians who've had to deal with this know it can be very frustrating trying to chase down a ground fault in a delta system. A lot of times we see deltas now on transmission and not so much in distribution. So it makes it a little easier to chase down a ground fault when you can see a breaker trip, which would be in a Y configuration. But we still do have these delta systems out there, so that you will see ground fault detection systems on these legs, and that's how we will determine which phase that we've got to go looking for. Again, not going to go too much into the theory of what happens with that ground fault and how the equipment still runs. Suffice it to say that this transformer is not grounded, so that has a lot to do with it. And there you have it. That's our video for today, or for this week, just the ground fault detection systems. If you get some value out of these videos, make sure you hit subscribe. The videos come out once a week. And if you'd like some more information about